Because if I want to call this definition the definition of circle, I think I need to modify it a little bit. So how about I do this? I say the set of all points in a plane. Why do I need to say that? And do you know what I mean by that? So, by the way, these things have names, right? That distance that is fixed is called the what? That's the radius. And the given point is very important also, and it's called the, well, it was the origin for this problem, right? I decided that for this problem, what I wanted to do was I wanted to plot points whose distance from the origin is 5. But what I'm about to do is I'm going to change the origin to some other point. And then what is it that I'll be moving? Well, this given point, do you know what it's going to be called? It's where you put the sharp part of the compass. Yeah, I'm just going to take part of that word. It's called the center. It's called the center. Okay? So when we say circle, you want to find two things. You want to find the center, and you want to find the radius. And then you know everything about the circle. Actually, is that true? If I said the center is 0, 0, which I did, and I said the radius is 5, which I really did, without telling you what this meant, okay, then you know everything you need to know about the circle. Okay. So if I'm going to plot this circle, well, I guess what I need to do is plot the coordinate plane here. And, well, let me go ahead and move out 5. 1, 2, 3, 4, 5. There was 5, 0. And here's 0, 5. And here's negative 5, 0. And here's 0, 1, 2, 3, 4, negative 5. And I guess my question was, do you guys know any other points that work? No? What's that? Not for the same points. But I saw some people drawing some really nice pictures. People were drawing circles, right? I saw it. I saw people drawing these nice circular arcs and said, well, any one of those points, if I'm right, any one of those points would be the same distance away from the origin that 5, 0, and 0, 5 are. Do you see that there's going to be infinitely many solutions? Let me give you one of them. How about this one? I claim that, what is that? 4, 3 is a point whose distance from the origin is 5. So how would I check that? Well, I guess what I need to do, I need to measure that line segment right there. Right? I need to see what that distance is. Now, how would I do that? The distance formula, right? We did that earlier in the year. What is the distance formula? That's the slope formula. That's the slope formula. You mentioned slope. All under a radical. It does have to do with a radical, right? So let's see. You said change in x squared. So I'm going to write, say, x2 minus x1 to call that the change in x squared. And I also have to add on the what? The change in y squared. Okay, so if we want to do that for our particular problem, what are we going to do? Well, we need to fill in, right? So the distance for this particular problem, what are we going to do? The square root of, what would it be? Well, the difference of the x's would be, I guess, 4 minus 0 squared, right? And the difference of the y's would be, what are we going to put? 3 minus 0 squared. And so I get the square root of, let's see, this is 16 plus 9. Look at that. Square root of 25 is 5. Do you believe me now? Okay. Can you find a point in the second quadrant whose distance from the origin is 5? Let's see where that would be. Negative 4, 3, right there. Do you guys agree that that distance is also going to be 5? You could argue by symmetry. You could argue by the fact that if I put in a negative, when I square it, I'm still going to get positive 16. You guys with me? How about another point? What do you have? Sure, negative 4, negative 3. How about another point? 4, negative 3. How about another point? How about 3, 4? What do you guys think? Right? If I do 3, 4, you'll see that's right on the circle as well. Okay? And by the way, I want to point out that when Dan was mentioning slope, he was on to something. Because, no, you weren't. Because the slope, no, you are. How do you find slope? What is slope? Rise over run, right? If I were going to find the slope, I would need to know how much the rise is. Well, how much is that rise right there? That's 3. And how much is the run? 4. And what kind of triangle is this, ladies and gentlemen? A right triangle. And I heard someone say, hey, you know immediately it's 3 and 4 and 5. And that's for those of you that know that, it's because someone taught you at one point that 3 squared plus 4 squared equals what? 5 squared. But see, we didn't know 5. We were solving for the distance. And actually, this may explain to you why the distance formula has a square root. Does that make sense? So, let me explain what the project is today. I want to write an algebraic equation for a circle so I can graph it. And I know what a circle is. It's a set of all points that are a fixed distance from a given point. So it really comes down to the distance formula. Okay? It comes down to keeping that distance fixed. And the fixed distance is going to be called what? The radius. The radius, okay? And so I can tell you where this equation comes from, okay? What we do is we say, well, the radius is going to equal, it's a distance, right? And it's going to be the distance of x minus, leave it blank for now, squared, plus y minus, leave it blank for now, squared. Why did I say leave it blank for now? Well, in our problem, what did we put into those blanks? In our problem, we put the origin, so what did we put? 0 and 0, right? But in general, what you're going to do is you're going to put the coordinates of the center. So the center is a point, and I'm going to give it the coordinates h, comma, k. Ooh, we saw those before. Where did we see h and k? Transformations. Remember, x minus h squared, and now we're going to have y minus k squared. And so h and k are actually going to be the center of your circle. Okay? So then the other thing is we don't really like the square root. And so you know what I'm going to do both sides of this equation? I'm going to square both sides. Right. And if I square both sides, I get the equation of a circle. And when I say it's the equation of a circle, I should really say with center h comma k and radius r. So this equation I'll give to you right here. Again, I'm taking the distance formula and I'm squaring it. That's all I'm doing. What am I going to get? Well, x minus h squared plus y minus k squared. I won't have the square root anymore. It's going to equal what? R squared, the radius squared. Okay? And that's going to be our standard form for the equation of a circle. So in general, if I want to write an equation for this circle, I can do that, right? I can take the form that's right there, and I can say, okay, I'm going to write x minus 0 squared plus y minus 0 squared equals what? Well, since the radius is 5, we're going to put 5 squared. I'm not going to leave it that way, though, right? What would we write? Yeah, x squared plus y squared and 25. So there we go. So now if I claim to you, hey, I have another solution, guys, it's negative 4, negative 3, what can you do to check? Well, you could put that in the equation, right? And you could check that negative 4 squared plus negative 3 squared indeed equals 25. Check. That's the point on the circle. You guys follow? Okay. So suppose I want to graph that very first problem, x squared plus y squared equals 25, and I want to use a graphing calculator. So I have x squared plus y squared equals 25. If I want to get the y by itself, I have y squared is 25 minus x squared. How do you get the y by itself? What do you write? Oh, remember that rule? You need plus or minus. Remember that? The square root of 25 minus x squared. See, then how do you graph it in the calculator? Well, if I go to the y equals screen, I don't have a plus or minus key. I do have a square root. 25 minus x squared. I could graph that. But if I graph that, oh, the window's bad. Sorry, guys. Let me hit zoom standard. It's only going to graph, what's that? Half the circle. And so you would need to go back and write negative square root of 25 minus x squared, which gets really annoying. And by the way, to make it look more like a circle, choice 5, zoom square, looks a little better. Now it'll look circular. Okay? You're better off just doing it by hand, honestly. Okay? But this gives you a how-to. So, number 1 says, let's see, we want to have a center of negative 1, negative 5, and a radius of 10. They want me to come up with an equation, and they want me to graph it. Okay. So, here, I'll graph it. It's kind of fun. Let's see, negative 1, negative 5. Let me plot the center. So negative 1, 1, 2, 3, 4, negative 5. There's the center. And now the radius is 10. So I just have to do things like count out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right there. What point is that? I guess it would be 9, negative 5, right? And I could go out here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, negative 11, negative 5. Okay? You get the idea. You'll make this easier on yourself if you have graph paper. You'll make this easier on yourself if you have a compass, actually. 4, 5, 6, 7, 8, 9, 10. Okay? So there's always these 4 points that are easy to plot. And then if I get lucky, it goes through another point as well that maybe would be interesting. I don't know. Do you guys have any points that it goes through that might be interesting? You might think about that. Anyways, in the meantime, let's think about what the equation looks like. So remember, I said that the general form is going to be x minus h squared plus y minus k squared equals what? R squared. So it's going to be 10 squared, right? R squared is the general form. And so now when we go to do R's, what should I write where it says x minus h? X plus 1 squared, right? Plus, and what do we write here? Y plus 5 squared equals 100. There's the equation I want. Nice. You guys follow? Okay. If I said to you guys, hey, I think I see a point on the circle, and it's 5 comma negative 1, would that be true or false? 3, 4, 5, negative 1. Is that really on the circle? I don't think so. What if I said to you guys, no, it looks more like it's 6, 7, 8, negative 1. I think that's on the circle. No, 7, negative 1. How would you be able to tell if any of those are on the circle? What's that? We can plug it in, right? We can plug it into the equation. So let's try those different points and see if we can find one that works. 5, negative 1, 7, negative 1, or 8, negative 1. And see if any of those work. So trying these points, it seems like none of these are on the circle, but if I go up here to, this one just missed the circle, this 8, negative 1, but if I go up to 7, comma 1, I would say that is a point on our circle because when I substitute in, I get 7 plus 1 squared plus 1 plus 5 squared. And if I work that out, that's 8 squared plus 6 squared. Hey, by the way, some of you are going to get this from geometry class because you're saying, oh, 6, 8, 10, right triangle. But even if not, you got 64 plus 36, 100. And 100 does equal 100 as we wish. Right? So if the x and y, when you plug them into the equation, make the equation true, then you say that's a point on my circle. It's the solution of the equation. Okay? And there are infinitely many solutions. That 8, negative 1 was almost a solution. Okay? So this is an approximate sketch. Okay. So I really like what the author does next in the book. He says, well, okay, so you can do that. Now can you recognize that we have a circle, say here in problem 7. That's a nice problem. So for problem 7, I'm going to write down that equation. x squared minus 4x plus y squared plus 10y equals negative 25. And I claim that is also a circle. And so what we're supposed to do is put it in standard form and then identify the center and the radius. Or maybe you won't get a circle. All right? And if so, you have to explain why. Well, okay, let's look at the problem. So, first thing I'd like you to do, and we've learned about completing the square. You guys remember that? We studied that back when we were studying what? I think the parabolas for the first time when we studied quadratic equations. Okay? But what I'm saying to you guys is, hey, let's do this. Let's write x squared minus 4x, and then I'm going to leave some space here. Because what we're going to do here is we're going to add something in a moment. Okay? Plus, and then here in parentheses I'm going to write y squared plus 10y, and I'll leave some space. And I'm going to say this equals negative 25. And you might say, well, why are you doing that? Well, the reason is what I would really like to happen is that eventually this becomes a perfect square trinomial so that I can write x minus something squared, right? Because we need x minus h squared. Does this make sense to you? I need to get x minus h squared so I can see what the center of the circle is. I don't have that yet. Similarly, I'd like to get y minus k squared, so I'll have something squared here. All right, so there's a little bit of work to do here. And you might remember how this works, right? What you do to figure out that number is you're going to take half of what? Oh, no? Yeah, half of negative 4. It's always half of the coefficient of x, and then you're going to do what to it? We're going to square it. Half of negative 4 squared. So what's half of negative 4? Yeah. But since we're squaring it, we're going to get what? 4. All right? So here's the rule. I'm going to put a plus 4 here, but then what else do I have to do? Got to go to the other side and write what? Whatever I do to the one side of the equation, I need to do the other. Plus 4, plus 4. The equation is balanced. I didn't change any solutions. I'm rewriting it. Okay. Now, let me get a different color out and try to fill in what goes here. So for this one, it's going to be half of, well, 10, right? Squared. By the way, what does of mean in mathematics? Multiply. That'll help you if you get a fraction. Sometimes you'll have half ofs and you'll get some fraction here. So 1/2 of 10 is 5. So I get 5 squared and I get 25, right? So what does that say I should do? We're going to add 25 in here, and then we're going to add 25 out there. Okay? So, let me ask this question. What's going to be the radius of my circle? Why did we say 2? Is that you, Brad, or Mitch? Is that Mitch? Why is it 2? Yep. So we're going to get 4 here, and you have to remember that that's r squared, and that tells you that the radius is 2. Very nice. Okay. And what about what goes here? Oh, that's a good question. Do you guys remember what goes here? Well, it's going to be h, that's right. But what's going to happen up here, since I have x squared minus 4x plus 4, that's going to be x minus what? 2 squared. Okay? What's that? No, actually, remember, you can always check your answer, too. Like if I have x minus 2, I want to check, is that the right thing to do? Well, what happens when I have x minus 2 squared? I get x squared minus 4x plus 4. I really do get what I had before if I work it out. You know, some people will write x minus 2 times x minus 2 to check. Okay? Whereas this one, can you guys figure out the binomial that this one is? Well, it's going to be y, but then what would I want to write next? This time I want plus and then 5 because, again, it's half of whatever that coefficient was, because when you multiply to check, say you do y plus 5 times y plus 5, you get y squared. You get 5y and another 5y. You always get double what was in there. That's why you take half of it, and then plus 25. I'm glad you guys have seen completing the square before, because I'm going much more quickly through it now than I did earlier in the semester. But if you need extra help, stick around. I'll help you putting those together, okay? But let me finish by saying, well, what's the center of this circle? Two, comma, and then you got to be careful here. Why is it negative 5? Yeah, we've seen that before, right? Remember, this is x minus h squared. So this was minus, so the h was actually 2. But when it says y minus k squared, what I actually did here was y minus negative 5 squared, if you want, right? Y minus negative 5 is the same as y plus 5. So if there's a plus sign in there, you'll need to take negative. And if there's a minus sign in the binomial, then you know it's just a positive. We've seen that before, back when we did transformations. I mean, guys, that's one of the reasons that I